Hello and welcome. We are going to work on Module 7, Lesson 2, finally. So in class today, today is January 27th, in class today we did finish up a little bit more on Module 7, Lesson 1, Part 2, but hopefully you can get that from the notes. If you cannot and you need a video, somebody reach out and I will work on that. But otherwise, let's go ahead and see what we can do here. All right, so Module 7, Lesson 2, finally. We need to start by reviewing what a function is. So review, what is a function? So in Algebra 1, you were taught a couple of different ways to decide if something's a function or not. The one that we're going to talk about today is when we compare the inputs and the outputs. So to be a function, each x, or input, must have a unique y, or output. So let's do some numbers to see what that would look like, right? So if we have, say, f of x, and then we have a list of coordinates for that, right? So we have 7 and 22, 8, 7, 9, negative 2, 10, negative 5, 11, negative 2, 12, 7, 13, 22. This is a function because I abbreviated because. If you don't know that that is an abbreviation for because, then you want to write out the word because. Because the x's do not repeat. Right? Our x's have to have a unique y. So if x shows up here twice and has different y's, then it doesn't have a unique y. So that would be wrong. Okay. Now, let's do what if we have the inverse of f of x. So this whole time that we've been working on the inverses, I'm not sure if you're aware, but if we had been putting them into a t-chart like this, if we put 7 into our function and got 22 out, then if we put 22 into the inverse function, we would get a 7 out. And if we put 7 into our input, we would get an 8 out. That is what the inverse does. So pause and try to fill up the rest of this. What would they look like? Welcome back. You are correct. They would be negative 2, 9, negative 5, 10, negative 2, 11, 7, 12, 22, 13. Now have a look at that. Knowing that our rule is to be a function, each x needs to have a unique output, a unique y. Is this a function? This is not a function because the x's repeat with different, so different, not unique, different y's. So for example, 22 repeats in our domain in the x column, and once it has a 7 and once it has a 13. So it is not a function because it has different y's for the same input. So when this happens, we have to limit or restrict what we're looking at. So we must restrict or limit the domain of our original function to, and then here we have to decide on what the rule is going to be. So in class, we stopped, we walked around, we talked, we made some guesses that were not correct. Please stop and do that. Stop and think. Okay, welcome back. So if you look at our f of x, right, we're looking at the original. If I use all of the domain numbers, then they're going to repeat. So I want it to be where I don't use 7 and 13. Ooh, 9 and 11 also repeat. So if I use 10 as my deciding, right, is that's my limit line, then I can go, well, we can use x, the domain, as long as x is greater than or equal to 10. Well, let's see what happens if we do that. So now let's rewrite these. So we have f of x, our original, but now with the limit limited to where x is greater than or equal to 10. So that's going to give us 10, negative 5, 11, negative 2, 12, 7, 13, 22. Well, that's a function because it was a function before, so we haven't changed much. We've just made it have less stuff in it, right? But now let's do the function of x inverted with these new rules. Well, now our inverse is going to be negative 5, 10, negative 2, 11, 7, 12, 22, 13. None of my x's repeat, so both are functions now. So both are functions. And that's what we wanted. So let's talk about this from a parent function perspective. So we are dealing with quadratics in this next lesson. So let's look at the parent function of a quadratic. If we have f of x equals x squared, then we know that our graph is going to look something like that. It is going to be a parabola, right? So then the inverse of that parent function is going to be the square root of x. Some part of that quadratic being an x squared, to get the inverse, we're going to have to take the square root of something at some point. So then, if you go to one of our parent function worksheets, the parent function for a square root is going to look something like this, as if it were a sideways parabola, but we only did one part of it. Because when x is negative, that would put a negative under the square root. Those are going to be imaginary numbers. Well, we don't have a way to graph imaginary numbers on this xy axis. So that's why the inverse of a quadratic is going to have a square root, and it's going to look something like that. All right, now let's go practice one. So we've got module 2, my bad, I apologize, module 7, lesson 2. Let's title it Inverse Quadratic Functions. Right? We were doing inverse linear functions, and now we're doing inverse quadratic functions. And our first problem is going to be p of x equals x squared plus 4. And we need to notice right away that this is a quadratic, so it needs a limit or restriction. It can be called either thing, so I want to make sure we have both. Our limit for the domain, so for p of x, our limit is that x needs to be greater than or equal to 0. So let's go through this. When I have my p of x equals x squared plus 4, how do I get the x by itself, right? Because our first step is still solve for x. Right, we're going to go minus 4 to both sides. We're going to change this to y. Y minus 4 equals x squared. From there, the only way to get x squared to become x is to take the square root of it. What you do to one side, you do to the other. So now we have the square root of y minus 4 equals x. Make sure the minus 4 is under the radical sign. There will be times when it is and isn't, so we need to be very careful about how we know when it's one, when it's the other. We're taking the square root of both sides. The y minus 4 is on the left side, so we take the square root of both sides. Now we're going to do the inverse of our variables. So we get the square root of x minus 4 equals y. This is the one that goes into the box, showing us that this is the p inverse evaluated for x. Now, we need a limit again, because inside that radical sign, right, under that radical sign, we cannot have a negative number because that would give us imaginary numbers, which we cannot graph. So we need to put our limit on that. How we do that is we say that x minus 4 has to be greater than or equal to 0. And let's write y so that we have that, because under the square root sign or the radical sign needs to be 0 or positive. Lots of ways you can write that, like it cannot be negative. You could write that it cannot be negative because we don't want an imaginary number, or we can't graph an imaginary number, stuff like that. So then we're going to solve for x here, plus 4 to both sides. So our limit here is that x has to be greater than or equal to a positive 4. And that is our limit for the inverse of p. And then we are still doing our checking, right, using composition. Checking by composition. And that will look like we have p composed with p negative 1. And then we'll do it again with p inverse composed with p. So this p, we start with our original equation at the top, which was x squared plus 4. Then I draw my beautiful arrow to show what I'm going to plug in for x. I am plugging in for x what I got in my box, which is radical sign x minus 4. So that's going to give me radical sign x minus 4, all of that squared, plus 4. Now, the beautiful thing about this is that if we have under the square root sign, but it's squared, the square root sign and the squaring like cancel each other out. So we get x minus 4 plus 4. Minus 4 plus 4 would be x plus 0. So we have x. Yay. When it turns out right, that means that we did our work correctly, right? That we got our inverse done correctly. And now we do it again. So let's start with our p inverse, which is what was in the box. So we do square root of x minus 4. Then we draw our beautiful arrow to show what I'm going to put inside. I'm going to put in my original, so x squared plus 4. Now I'm going to write that out. So we get square root of x squared plus 4 minus 4, all under the square root sign. Right, because this negative 4 becomes this negative 4, like they're the same one. So then we get square root of x squared plus 0. 4 minus 4 is 0. So we have square root of x squared. Well, that gives me x times x. So the square root of x times x equals x. If I lost you here, let's think about that in real numbers. If I had square root of 25, that is 5 times 5. The square root of 5 times 5 is 5. So when you have matchy-matchy underneath, you take out just 1. We have matching 5s, we take out 1. Square root of y squared is y times y, So it's just a y. Okay? These are just examples in case you needed to see it better. And that is how far we got in lesson 2. Have a great day.